Hello, everyone. So my plan for our remote learning is that I'm going to take and post videos of our various lessons that we're doing, and then you guys will be able to follow along just like what you would if we were in class. So going through, as you can see behind this video, we have the slides just like what we would when we're doing it all together in class. So this will feel very, very similar, I'm hoping, to exactly what we do in class. Um, so we're going to be looking at various lessons throughout this time. I will have a key word in each of the videos that you have to take and listen for. I will make it very obvious. I'll say it numerous times over and over to ensure that you get the keyword. So don't worry, it's not just a one-time thing. If you miss it, you miss it. But that keyword will be for a grade. So there'll be a place on Canvas for you to take and submit that keyword to get credit for it. So make sure you are watching the entire video to listen for that key word. Now, I'm hoping you guys have your workbooks, but if you don't, I will be taking and posting PDFs of our practice problems. That way you could take and look off of the PDF and then be able to write your answers down on a separate sheet of paper and then take pictures of that and send it back in to me. Now, if you have a printer and you want to print the PDF and write your answers right there on the practice problems, like what you would for homework, that's perfectly fine as well. As long as you have a printer, whatever works best for you guys. If you don't have the printer and you have to take and look off the PDF and then write down on a separate sheet of paper, just make sure you're saying what the problem number is. Make sure you have the lesson, since we'll have multiple lessons within this. So make sure you have what lesson it is, what number it is, any sub parts. So if there's an A, B, and C, make sure you have one A, B, and C. That way I can be able to grade your homework easier. Also, make sure when you're doing your homework, you show your work and you make sure your answer is obvious. You circle it, you box it, you highlight it, something. I need to be able to see that answer nice and plain and clearly, because obviously, since we're doing this all digitally, looking at your answers via a picture is going to be a lot harder than looking at your answers when I have the workbook right in front of me. So keep that in mind as you're taking and doing your work for the practice problems. And also for those of you who may have slightly sloppier handwriting or very light handwriting, try to write a little darker and a little neater. So that way it's easy, it shows up in the picture nice and crisp and clear. So that way I can grade it and you don't have to lose points because I can't read something. Okay, so that's just the little info bit there. I will have all of that wrote out on the announcements section of our Canvas as well. That way you don't have to worry about remembering all of what I just said. You can look back and see what I said and have that to hard copy, since I did just say a lot of information. So with that being said, we are going to jump right into our lesson. It is lesson 6 from our workbooks. So we are looking at absolute value and numbers on the number line. See if I can get this positioned properly. Okay, so as you can tell, we have our jumping flea. So a flea is jumping around on a number line. We've got our number line right up here. And the first one says, if the flea starts at 1 and jumps 4 units to the right, where does it end up? Well, if we start at 1 and then go 1, 2, 3, 4, we're going to end up at 5. So for our first answer, it's 5. So with the number line, our basic, just counting it out, seeing where we go, and going the appropriate direction. So it's at 5. Now, the second part of this question asks, how far away from 0 is this? So how far from 0 is 5? Now, this may seem like a strange question, but it'll make sense as we progress through this. It's 5. So it's 5 from 0. All right, our next question, which you guys can't see on the slide, but I do have right here, it says if the flea starts at 1, so still starting back at our 1, and jumps 4 units to the left, so now we're going to the left instead, where does it end up? So starting at 1, we go 1, 2, 3, 4, so we end up right there. And if we end up there, what value is that? Well, it's 3 after the 0, so it's -3. Now, just like before, second part of the question, how far away from 0 is this? Well, it's 3 from 0. All right, our third question. If the flea starts at 0, so now we're starting at 0 instead of 1, and jumps 3 units away, where might it land? So it's not telling us if we have to go to the left or to the right. Now it's just telling us it's 3 units some direction. Well, 3 units to the left will give us -3, just like we had before. But 3 units to the right will give us +3. Oops, one over. So our opposites. And for question D, if the flea jumps 7 units and lands at 0, where could it have started? So if we think about that, we're ending up at the 0. We know it's traveled a distance of 7, so that means it could have came 7 from the left, which would leave us at -7. Or it could be 7 from the right, which would put us at +7. So looking at our opposites here, when we do distances on a number line, there are always opposites. We can go either to the positive side or to the negative side, depending on what number we're ending up at. So at our 0, using that as our center point, then we have opposites. If we use a different number for our middle, then it won't be true opposites, but they'll be the same distance away. Okay? So we've got a couple more questions with this jumping flea. Let me grab the next slide. So I mentioned how we'd be talking about absolute value today. So that's exactly what we've been looking at. So the absolute value of a number is the distance it is from 0. So this is all about distance. That's the key thing with absolute value. Most times when people think about absolute value, they just think, oh, any number, the absolute value of it, it's always going to be positive. Doesn't matter if it's positive to begin with or negative to begin with, we always get a positive answer. Now, the reason being for that is because absolute value is a distance. We're just counting how far the number is from 0 originally. And we can't have a negative distance. It's not possible. Now, I know you're probably thinking, well, I can go backwards. That's not negative. Negative distance doesn't exist. Positive distance is the only way we can go. Yeah, we can walk backwards forever, but it's still a positive distance because we're still going a positive amount of feet or miles, depending on how far we actually do walk for. So no matter what, distance will always be positive. If you get a distance that's negative, you probably did something wrong, so you may want to check your work. All right, so with this question then, talking about the absolute value, the flea is currently to the left of 0, and the absolute value of its location is 4. So where on the number line is it? So if we know that it's over on the left somewhere, and we know it has a distance or an absolute value of 4, then we go 4 to the left from 0, which will give us -4. So it's currently at -4. So for F, if the flea is to the left of 0 and the absolute value of its location is 5, where on the number line is it? So as you're noticing, there's a lot of absolute value being said here. Absolute value is your key word for this lesson. So make note of that. Absolute value is your key word for this lesson. You will need to submit that on Canvas. You'll see a place to do so. You will get credit for it. So once again, absolute value is your key word for this lesson. All right, so back to F, sorry. If we went 5 to the left of 0, we would be at -5. All right, and our final question with our deer jumping flea. If the flea is to the right, so now we're going to the right this time, of 0, and the absolute value of its location is 2.5, where on the number line is it? So once again, absolute value, we know the distance, and we also know that it's to the right. So instead of going off to the left, we need to move to the right this time. So go over 2.5, which puts us at a positive 2.5. So our answer for this one, falling board, is a 2.5 because we know it has to be positive since it's to the right. Okay, so absolute value, like I said, it's all about distance. How far did we have to take and go from that value to get to 0? And it's always, always, always going to be positive. You can't have a negative distance. All right, our next set. So for this, we can have full screen, make it a little easier for you to see. Okay, so we use the notation. So this notation right here, this is how we notate absolute value. It's two vertical lines on either side of our number. So don't mistake them for one. A lot of people, so like in the case down here, you might think this is 11.81. It's not. The absolute value of 1.8. So most times, especially in your workbooks and everything, they'll have it bolded. So the absolute value bars will be a little bolder than what the regular numbers will be. So it's a little easier to see. It's a little harder to do that here on the whiteboard, but that's what those absolute value bars look like. So we use the notation, the absolute value of -2, to say the absolute value of -2, which means the distance of -2 from 0 on the number line. So for A, what does the absolute value of -7 mean, and what's its value? Well, it means, the absolute value of -7, or just like we have up here, we have two different notations for what that means. It means the distance -7 is from 0 on the number line. So once again, it's all about, wrong direction. It's all about the distance that we're taking and moving. Absolute value will always reflect distance. All right, so the second part of that question, though, it wanted to know what it meant, but it also wants to know the value. So what is the value of the absolute value of -7? Well, if it has to be a positive value, then our answer is 7, because -7 is 7 away from 0. So the value is 7. All right, so what about on B? What does the absolute value of 1.8 mean, and what is its value? Well, it means the distance 1.8 is from 0 on the number line. And then once again, it wants to know what its value is. So what is the absolute value of 1.8? Well, how far is 1.8 from 0? It's 1.8. Perfect. All right, so going to shrink the video screen a little bit so we can see the context for these next few questions. So looking here, we're talking about elevation and temperature. So for this first one here, it's saying, so look at the number 1 here, it'll have the whole context for you to refer to. A part of the city of New Orleans is 6 feet below sea level. We can use -6 feet to describe its elevation, and the absolute value of -6 feet to describe its vertical distance from sea level. In the context of elevation, what would each of the following numbers describe? So looking here and also looking over here, we could see 25 feet. So what does that represent in this situation? Well, just like New Orleans saying -6 feet meant 6 feet below sea level. So saying 25 feet, it means 25 feet above sea level. Since we have that positive number, we know it's going to be above sea level. So for the B, it's the absolute value of 25 feet. Well, what does that mean? It means the distance between 25 feet, I'm going to abbreviate feet, above sea level and sea level. So it's just showing that vertical distance. So how far did we have to go from 25 feet above sea level to the actual sea level? It's looking at the distance. Note that keyword there with absolute value. Note, distance is not your keyword for this lesson. It's just a crucial word for our absolute value. Absolute value, remember, is our keyword for this lesson that you'll have to submit. All right, for C, -8 feet. So what does -8 feet mean? 8 feet below sea level. Excellent. So now D, once again, just like with B, we're doing the absolute value of our value from C. So the absolute value of -8 feet. So what does that represent? Just like before, it represents our distance. So the distance between 8 feet below sea level and sea level. Oops. So you all can see that. So like I said, absolute value, it's all about the distance, and it's always, always, always going to be positive. It won't ever be negative when we're dealing with distance. Okay, so one last slide for you guys that we'll be doing on this lesson. More with elevation and then looking at temperature as well. So make this a little bigger so you can see it easier. All right. Oh, it looks like I erased part of it. Let's see. So the elevation of a city is different from sea level by 10 feet. Hopefully you guys can still read that. Name the two possible elevations. So we know with absolute value that we can have two possible values, just like we did before on that number line when we knew that the flea jumped 7 units. It jumped 7. And we didn't know which way it came from. We just knew that it ended at 0. So we had the possibility of 7 and -7. The same is true here. We know the difference from sea level is that 10 feet, but we don't know where it started from. It could be positive 10 feet. So 10 feet above, or 10 feet below. So there's always two possible values when we're dealing with absolute value. If you're given what the absolute value is, to figure out what the original was that you were taking the absolute value of, there will always be those two possibilities. All right, back to the presentation. So our next context that we have, oops, right there, is dealing with the temperature. So we write -5 degrees Celsius to describe temperature that is 5 degrees Celsius and below freezing point. Sorry, don't mind my cat jumping in this video on you guys. Okay, sorry, let me repeat that. We write -5 degrees Celsius to describe a temperature that is 5 degrees Celsius below freezing point, and 5 degrees Celsius for a temperature that is 5 degrees above freezing point. So in this context, what do each of the following numbers describe? So we've got 1 degree Celsius, so that describes 1 degree above, or 1 degree Celsius above freezing. Now, what about -4 degrees Celsius? That represents 4 degrees Celsius, excuse me, below freezing. All right, what about C? So now we've got the absolute value in there. Sorry if it's a little shaky. My cat's attacking the computer. So for C, the absolute value of 12 degrees Celsius. So if we look and think about what absolute value means, it means the distance. So the absolute value of 12 degrees Celsius is the distance between 12 degrees Celsius and freezing point. Now, for D, we have the absolute value of -7 degrees Celsius. So same idea, we're still dealing with the distance. So distance between 7 degrees, -7 degrees Celsius and the freezing point. So once again, another case in which absolute value represents our distance. It's always going to represent distance, no matter what. It'll always be the distance. All right, for number 4, which temperature is colder? -6 degrees Celsius or 3 degrees Celsius? Well, we're just thinking about it on a number line, which is further to the left, -6. So -6 degrees Celsius is colder. All right, for B, which temperature is closer to the freezing temperature? -6 degrees Celsius or 3 degrees Celsius? Well, now we're thinking about distance. So is -6 closer to 0 or is 3 closer to 0? 3 is closer to 0. And then the last one, which temperature has a smaller absolute value? So once again, absolute value specifically means distance from 0. So once again, which one is closer to 0? 3. And our justification is that it's closer to 0. So like I've been saying, a lot of what you're going to see on your practice problems for this lesson are absolute value problems and dealing with what that represents, what that actually means in the case of each context that you're dealing with. So make sure you remember absolute value will always give you a positive value, and you can never have a negative distance. It's just not possible. Yes, we can go below sea level and have a negative elevation, but that does not mean that we have gone negative feet. It just means that we're below sea level. So keep that in mind as you're taking and working on this. Once again, your keyword for this lesson is absolute value. So there'll be a place for you to submit that to get some credit for watching the video. Once again, if you don't have your workbook, that I will have the PDF available for you guys to look at, to take and answer your practice problems. So if you have any questions, because I know this can be pretty confusing and a lot of new stuff going on. So if you have any questions, feel free to email me or message me on Canvas. Either one, I will try my best to get back to you as soon as possible. Your contact person is Ms. Murphy. So if you can't get a hold of me, you can always contact her and she'll be more than happy to help you with any of your confusion or needs. And if she doesn't know the answer, then she can get a hold of me and we can figure out what you guys need and how to best help you. All right. Good luck and happy math time.